Hey guys, welcome back to my channel. So today's question is based on differential equations. It's a chapter in calculus in 12th mathematics. And today's question is based on linear type, right? So first of all, what is a linear type? The linear type looks like this, right? You should see a form of dy by dx plus p of y equals to q, right? This is the form we should see. If you look closely, we actually see this form, but we have to make slight adjustments. What do we do? Start with dy by dx. You write your p in one bracket so that it is clear to you. We will write 2 tan x in the bracket and we'll keep the y outside and we are going to keep the q outside. So remember that when you write in this form a differential equation, it is representing a linear differential equation. And P and Q are supposed to be functions in X or they can be constants. So be careful about that. Now, if you see, P is a function of X, Q is also a function of X. So the next step is we will go ahead and find the integrating factor. That is step one. Okay. So integrating factor. So you can assume step one is writing in this form or finding your P and Q. And then integrating factor is your step two. What is the formula for integrating factor? It is e to the power integral of p dx. Let's substitute the value of p. So p ka value is 2 tan x dx, right? Now remember, treat this as an integration question and keep the e as it is. Okay, it's just like copy paste. So copy the e and remember integration, the constants or the coefficients of functions do not participate in the integration or differentiation. So you take them out so that your calculation becomes easier. So what do we have to do? We have to integrate tan x dx. And what is the integral of tan x dx? It is ln sec x. So our integrating factor will become e to the power 2 ln mod sec x. Ln, if you guys know, it is nothing but log with the base e. So now, so few people will leave the question over here, right? But don't do that because it's not done yet. There is a formula in mathematics or in logs where it says a to the power base log ab is actually b. So if you have log in your power and the log ka base is same as the entire base of the function, then you just copy the b outside. It's a formula. So remember this and we can apply this formula in this question. How? You know that a log b can be written as log b to the power a. So this 2 will go on top and it will become e to the power ln mod sec x ka whole square, right? You can write it as whole square. Now sec x whole square is nothing but sec square x. Now look at this. E ln, as I said, ln is nothing but it is, if I write it here, I'm going to write it in bracket. Log E B can also be written as ln B. So whenever you see ln, it's nothing but log of E. So if you see the base is E, so E is in the entire base, log is in the power, and then E is again. So we can straight away take out sec square x. So our integrating factor is sec square x. So be careful about this formula. A lot of students forget to fully simplify it. Now we got an integrating factor, which is step two. Third step is you can straight away write the general equation will become y times integrating factor is equals to integral of q times integrating factor dx. So what is the integrating factor? It is sec square x. So y sec square x integral. What is the value of q? The value of q is sine x, right? So sine x times sec square x dx. Left hand side is already done. Do not do anything on the left hand side. You just have to integrate the right hand side. So let's change. Now, when you see this integral, it's not a direct formula. When you don't see a direct formula in trigonometric expressions, change all t ratios into sine and cos for simplicity. When you do that, you start to see something. So we can write this as sine x upon cos x, and I can form another bracket of 1 upon cos x dx. So I've separated the cos square x as cos x into cos x in the denominator, and I've taken sine x and cos x together and 1 upon cos x together. Why? Because I know that tan x and sec x dx ka integral is, those who you know, remember, integration is nothing but the reverse of differentiation. So when you have to remember a formula, think, what do you differentiate that you get sec x tan x? It's actually sec x, right? So when you integrate this, you are gonna get sec x plus c, right? This is our general equation. Okay, we still haven't got the complete answer. Why? Because we have been given this value. Remember, when this value is given, when x is something and the y value is given, so basically coordinates are given. In this case, we have to find the particular solution. Okay, this is a general solution which contains your c. Particular solution requires you to find this value of c using the condition given and then substitute it back to get the final answer. So let's substitute. When y is 0, so when x is pi by 3, y is 0. Okay, so let's substitute. We are gonna write 0 times sec square x will be 0, but still I'm gonna write it sec pi by 3 plus c. 0 is equals to, what will be sec pi by 3? I don't know. I'm gonna change it to 1 upon cos pi by 3. Okay, I know. I'm just saying that if you keep it simple, okay, everything change it to sine, cos, and tan. Now, cos 6, this is pi by 3, which is 60 degrees. Pi equals to 180 degrees. So pi by 3 will be 60. So technically, what is cos 60? It is 1 over 2. So 0 is equals to 1 over 1 divided by 2 plus c, or c equals, this 2 is going to come up. Okay, whenever you have a fraction in the denominator, you change the division like this. Let me show you. I'm gonna, okay, I'll not switch it so that to avoid confusion. I'm gonna first write 1 times. Remember, this division changes to multiplication and you reciprocate the denominator fraction and you bring it up. Okay, that is the formula, plus c. 0. Or c is equals to how much? 1 times 2 is 2, or c is equals to minus 2. Take this value, hence particular solution will be 5 sec square x equals to sec x minus 2. This is our answer. Okay, hope you guys like the video. If you want to follow for more updates, please subscribe and follow my Instagram channel. Thank you.